Hi, this is Mrs. Dorman, and we are going to solve power and radical equations. All right, so let's try this first one. We want to solve 2x squared equals 32. So we want to figure out what x is. We want to isolate x. I'm going to circle x, and we need to figure out how to get the x by itself. We have to undo the operations that are being done to x. So it's being squared and multiplied by 2. So I'm going to divide by 2. We want to do that first. All right, so I have x squared equals 16. I know that 4 squared is 16, so I know my answer is 4. But anytime we take the square root when we're solving, we actually get a plus or a minus. We get two solutions. So if we take the square root of both sides, which is what we do to cancel out the squared because they are inverse operations of each other, whenever we take the square root, it's actually plus or minus that we put in front of it, because if I square 4, I get 16, but also if I square negative 4, I get 16. So anytime we're taking a square root when we're solving, don't forget to put the plus or minus in front when you take the square root. All right, we're going to try the next one. X minus 4 cubed equals 15. So to undo the cube, I want to do a cube root. And that way I just have x minus 4. I no longer have the cube because I took the cube root. That's the inverse of cubing. It cancels out. I don't know the cube root of 15. It's a decimal. It doesn't work out perfectly, so I'm just going to leave it cube root of 15. And then we still want to get the x by itself, so I'm going to add 4. Cube root of 15 plus 4, and we usually write the radical at the end, so I'm going to switch this around. 4 plus cube root of 15. If you leave it the first way, that's totally fine, but this is the right way, like the mathy way that we're supposed to write when there's a radical in our answer. The radical goes at the end. So 4 plus cube root of 15. All right, let's look at number 3. 5 equals the square root of x plus 1. So I want to undo. So again, I'm trying to get the x by itself. I need to undo these operations. 1 is being added to x, and then you take the square root. So then I want to square both sides because I don't want that squared there anymore, or the square root there anymore. So if I square both sides, that's the inverse of square rooting. They cancel each other out. So that's why I squared both sides, so I no longer have the square root. I still have the plus 1, so I want to subtract 1. 24 is x. I'm going to plug this one in. We should be plugging our answers in just to double check. So let's double check our solution. So I'm going to take the original equation, and instead of x, I'm going to plug in what I just got for x, 24. And this looks like it's making sense because if I get 25 and take the square root of 25, that is 5. So it's correct. And you might be thinking, but square root of 25 is plus or minus 5, but this is just a positive 5. And whenever we're simplifying, if we plug in a number in and we're just simplifying, then we just want the positive root, unless there was like a negative in front of the square root. So it's just square root of 25. If we're just simplifying that, we just take the positive root, which is just 5, positive 5. So our answer is 24. It worked. It's correct. Let's try some more. All right, number 4. X minus 4 squared plus 1 equals 21. So I want to get the x by itself. I'm trying to just isolate that x. I want to undo all these other operations so that I just have the x. If I kind of think about what operations are being done to x, if I plugged in a number, it's subtracting 4 and then squaring and then adding 1. So to undo those operations, I'm going to subtract 1 first. And now I have x minus 4 squared. I'm going to undo the squared. The inverse of squaring is taking a square root. If you take a square root and square, they cancel each other out. And then I'm going to remember that every time I take the square root, I want to put plus or minus in front of the square root. I know I could simplify square root of 20. Instead of writing it as decimal, I just want to leave it as a square root, but square root of 20 can be simplified, and you might have maybe done it like this in the past, where you can break down 20 into factors. So 10 times 2 is 20, and I know 5 times 2 is 10. So you break it down into its prime factors, and then you look for pairs for square roots. There's a pair of 2's, and that pair goes on the outside. There's a 5 left over, so that goes on the inside. So square root of 20 is 2 square root of 5. Another way to do that is 20 is 4 times 5. I could have done it this way, and then once I saw the 4, that's a number that I could take the square root of. So square root of 4 is 2, and then again, I still just have the 5 left over. Either way, I get x minus 4 equals plus or minus 2 root 5, and then I still need to add 4 because we still want x by itself. So I'm going to rearrange this. I can't add the 4 to the 2 root 5 because it has the radical in it, and 4 doesn't have a radical. They're not like terms. We can't just put them together, but we can write them out. I'm going to put the 4 first because remember I talked about if there's a solution with a radical in it, a root, some sort of root in it, it goes at the end. So 4 plus or minus 2 root 5. All right, we're going to look at number 5. I want to get the x by itself. I'm looking for the x. I'm trying to find what I want to solve, and I'm thinking about what I need to undo, what operations I need to undo to get that x by itself. So x is, there's a cube root being taken of x, and 4 is being added. So to undo that, I want to subtract 4. And then to undo a cube root, I want to do the inverse of that so that I just have x. I don't have cube root of x. So I'm going to cube both sides. 8 cubed means 8 times 8 times 8, which is 512 equals x. And last one, number 6. 2 times the square root of x plus 20 equals 16. So again, solving for x, I'm going to circle what I'm trying to solve. I want to get that by itself. That means I need to undo the other operations being done to x so that I could just isolate x. X is, if I plugged in a number for x, we're adding 20, taking the square root, and then multiplying by 2. So then to undo that, I want to divide by 2 so that I just have square root of x plus 20 equals 8. Okay, now I want to undo the square root. I don't want a square root. I just want it to go away. So I'm going to do the inverse operation, which is squaring. And then 8 squared is 64. And then I just have x plus 20. I don't want x plus 20. I just want x. So I'm going to subtract the 20, and I get 44. Okay, now we're going to try number 4 and number 6 with graphing and compare how the solution from our graphs compares to these answers that we're getting. So I'm going to go to the next slide. That was this problem for number 4. Let's see, it was 4 plus or minus 2 root 5. To number 6, that was the answer for number 6, 44. And this is saying we want to solve x minus 4 squared plus 1 equals 21. By graphing, and then how does the solution compare to the answer to number 4? So if we look at the graph, it's already done, and what happens is you just graph each side of the equation. So we have this side of the equation here, x minus 4 squared plus 1, that's here. So we make that graph, that's this purple parabola. And then we graph the other side of the equation and make a little equation with that, y equals 21, and that's that horizontal blue line. And then we look at our intercepts for the two graphs. Because we're solving this equation, we want to know when they're equal to each other. So that means when they'd be intersecting. They intersect here and here. So what does that have to do with our answer for the previous, for when we actually did number 4? So I'm going to go back to the answer and write it. So I'm going to write that here. 4 plus or minus 2 root 5. We said that that was a solution. That's actually two solutions. It's for plus 2 root 5 and for minus 2 root 5. But in the graph, I'm looking at decimals. So I want to put these two solutions in the calculator for plus 2 root 5 and for minus 2 root 5, just so I can convert them to decimals. And then I could compare it to these numbers, see if I'm getting the same thing. Okay, so when I put 4 plus 2 root 5 in the calculator, I get 8.472, and it keeps going, but I'm going to round it to that decimal place too. And then 4 minus 2 root 5, I put that in the calculator, and I get negative 0.472, and again, that keeps going, but I'm going to round it to there. And if I look at the x values here and here, those are my solutions. So that's one way we can either find the solutions by graphing. We would graph, find where the graphs intersect at those points, or it could be one point that they intersect, or two, or maybe they don't intersect at all. We'd find where the graphs intersect, and then we would look at the x values, because that's what we're solving. We're solving for x. So the x part of the coordinate is our solution. So I could either find the solutions from the graph, or I could solve just algebraically and then use the graph to check my solution. In this case, I got the same thing. My solution from solving was correct. I'm verifying it from the graphs. We're going to try that one more time. So this was the problem from number 6. It was solving 2 square root of x plus 20 equals 16. And we're going to do the same thing. We're looking for where the two graphs intersect. And it's actually already there. So 44 and 16. And if I go back, x value from the graph. So again, we're getting the same thing. You can graph both sides of the equation. 2 times the square root of x plus 20. That's one equation. And then 16, we graph that, make little functions for them. And wherever they intersect, the x value of the coordinate that they intersect at is the solution to the equation.